Hello friends, welcome back to SPROM's lecture series, and today we will discuss two sample t-test, which is also called as independent sample t-test or unpaired t-test. The two sample t-test is conducted to determine whether there is any statistical significant difference in the means of two independent samples which are unrelated samples. The two populations or the samples are included in the study are treated separately. The independent sample t-test is also called as unpaired sample t-test. Before we actually go and perform the independent sample t-test, let us see how to formulate null hypothesis and alternative hypothesis for the unpaired sample t-test. Since here we will be comparing two independent population mean differences, the hypothesis statements can be formulated as follows. The null hypothesis statement can be stated as the mean of two independent population is equal, or we can put it in other ways as there is no significant difference in the mean of two independent populations. And the alternative hypothesis statement can be formulated as H1, the population mean of two independent population is not equal, or it can also be stated as there is a significant difference in the mean of two independent population. The upward tailed hypothesis statement can be stated as the mean of one independent population is greater than the second population mean, and the lower tail hypothesis statement can be stated as the mean of one independent population is lesser than the second population mean. So let's understand how to perform the independent sample t-test with the following example. Suppose a researcher wants to conduct a study of increase in body weight in two different populations with two different food types. That means here the researcher is including two different populations, as well as each population will be treated separately with different treatment conditions. Suppose one population included in the study is from IT industry who were given daily one burger for 3 weeks. The second population included in the study is from the hotel industry and who were given daily one donut for 3 weeks. After giving the food type daily 1 for 3 weeks, the increase in weight of the population is as given in the table. The table shows that the 10 number of respondents and their increase in weights after having burger in the second column and with donut in the third column. The calculated means are as shown in the respective columns. Since we have to calculate x minus x bar square values for both the population data set, first we will subtract the mean values of population 1, that is x bar 1, which is 2, from each of the data set as shown here. So in the third column we will write down x1 minus x1 bar values for the population 1. Then we want the squared values of these differences of third column, that we will write down in the fourth column as shown in the table. And since we will be requiring summation values of this x minus x bar square values, and the summation value that obtained is 2. The similar calculation we will do for the hotel industry group to whom the donut was given, the x2 minus x bar 2 value and its square value of differences and the summation value. So for x1 minus x1 bar square, the summation value obtained is 2, and for x2 minus x bar 2 square value, the summation value that we have obtained is 4. In the next step, we need to calculate the sample variances. So the sample variance is the squared value of standard deviation, and hence the formula for sample variance is as given here. So sample variance is equal to summation of x minus x bar bracket square divided by n minus 1. So putting all the values in the given formula as shown in the sample variance for IT industry population, the value what we got is 0.22, and for the hotel industry the value we got is 0.44. So 0.22 is the sample variance for IT industry and 0.44 is the sample variance for hotel industry. Now we have calculated variances and mean values for both the given population. The formula for independent sample t-test is t is equal to the mean population of 1 minus mean population 2 divided by under root of sample variance of population 1 divided by n minus 1 plus the sample variance of population 2 divided by n2 minus 1. Since we have two data sets, so the degree of freedom is calculated with the formula like n1 minus 1 plus n2 minus 1. After putting all the values in the formula of unpaired t-test, the value obtained for the t-statistics is minus 7.57. The degree of freedom value obtained is 18. Next is we need to compare the calculated t-value with the table value to make the decision on hypothesis. So in the statistical table at the degree of freedom 18 and the two-tailed significance value alpha at 5% significance level is 0.025. Hence the table value is 2.10. And since minus 7.57 is falling in the left hand side of the normal distribution curve, this table value will also become minus 2.10. Decision: since the calculated t statistics, that is minus 7.57, is greater than the t critical value minus 2.10, we can reject the null hypothesis. And thus we can conclude that the mean of independent population 1 is smaller than the mean of population 2, that is there is lesser increase in the body weight of population 1 than in the population 2, that is the increase in body weight in both population is significantly different. That's all from my end, guys. Hope this video was informative to you. If you like this video, press the like button, share with your friends, and don't forget to subscribe. Thank you, all the best, and do well.